researchers have invented a thin-film transistor that could lead to the development of flexible electronic devices with applications such as display technology, medical imaging and renewable energy production. Researchers were exploring new uses for thin-film transistors (TFT), which are most commonly found in low-power, low-frequency devices like a computer display screen. Efforts to improve the performance of transistors have been slowed by the challenges of developing new materials or slowly improving existing ones for use in traditional thin-film transistor architecture, known as the metal oxide semiconductor field effect transistor (MOSFET). Instead of developing new materials, researchers from the University of Alberta in Canada improved performance by designing a new transistor architecture that takes advantage of a bipolar action. Instead of using one type of charge carrier, as most thin-film transistors do, it uses electrons and the absence of electrons referred to as holes to contribute to electrical output. Their first breakthrough was forming an inversion hole layer in a wide bandgap semiconductor, which has been a great challenge in the solid-state electronics field. Once this was achieved, we were able to construct a unique combination of semiconductor and insulating layers that allowed us to inject holes at the MOS interface, said Jem Shout from University of Alberta. Adding holes at the interface increased the chances of an electron tunneling across a dielectric barrier. Through this phenomenon, a type of quantum tunneling, researchers were able to achieve a transistor that behaves like a bipolar transistor. It is actually the best performing TFT device of its kind, however. This kind of device is normally limited by the non-crystalline nature of the material that they are made of, said Ken Kadian from University of Alberta. The dimension of the device itself can be scaled with ease in order to improve performance and keep up with the need of miniaturization, an advantage that modern TFTs lack. The transistor has power handling capabilities at least 10 times greater than commercially produced thin-film transistors. Usually tunneling current is considered a bad thing in MOSFETs and it contributes to unnecessary loss of power, which manifests as heat, said Shout. What we have done is build a transistor that considers tunneling current a benefit, she added. The findings were published in the journal Nature Communications.